Saurabh, close the door. Close the door. Okay. Good afternoon, everybody. Sorry for the 40 minutes delay. It was beyond our control. Welcome back to the GAN course, Next Gen Supply Chain, Harnessing IoT, Digital Twins and AI-driven Simulations. Today is the fourth day of our GAN course, and we are going to talk about the optimization and simulation techniques for supply chain analysis. Yesterday, we discussed how to model your supply chain in any logistics, how to do the greenfield analysis. Greenfield analysis is mainly used for facility location allocation problems. Then we tried to convert those results of those facility greenfield analysis into the simulation model, and then we are going to add couple of additional cost into that model. So initially what we will do, we will cover those remaining two examples of yesterday's case study, and then we will move on to the optimization and simulation. So I hope you have opened the any logistics. So let me go on to that first. Okay, we covered these parts. Tell me some performance KPIs, guys, for greenfield analysis. What was the cost for single distribution center? What was the cost? What was the flow amount? Sorry? Okay, let me see. Okay. What was the flow? 7,104. Okay, let me see. 7,104 meter cubic. What was the flow cost estimation? 1.59 million. Am I right? Meter cubic in 2 kilometer, because it calculates the basically the flow this cost considering the demand and the distance. That's why you can see meter cubic, how many products it is flowing, and the kilometer. Okay, and then new sites locations we found here. Okay, but one important thing I told you. What was that important? Is it a real location? No. Why? Yeah, so basically this GFA experiment, it doesn't consider whether it is a mountain, sea or anything. Okay, it asks you to locate anywhere based on that center of gravity method. And if you want to exact location, what do you want to do? There is another option here which is not available in the free version. Okay, GFA with roads experiments. When you run that GFA with the roads experiments, you will get the exact location. It is not in the on any mountain or any sea. Okay, so that's the your first example. And what was our problem? We wanted to locate only one DC. Am I right? And then second, what was the criteria? What was our aim? Service distance. What was that service distance? 300 kilometer. From where to where? Where do you want to? Distribution center to customers. So this was, and then you can see your flow cost reduced by almost 28%. And then distance you can see again 27.38%, and the flow remains constant. Why did flow remain constant, guys? What is the reason behind that? Yeah, demand is constant. We haven't changed the demand. What we did, we just changed our criteria, input criteria. The criteria what we did in initial case, we wanted to locate only one DC. In the second case, our focus was on the maximum service distance from the potential DC location to the all customers, and that distance was 300 kilometers. So now what we want to do now, we want to analyze these two distribution centers model further, because some costs were missing in that one. What were those costs? facility location cost, processing cost was not involved in that model. So we need to add those additional cost, and then we want to see what is the performance. So let me convert it now. You can result. If you go here and if you convert this scenario, then it will ask you basically whether you want to convert whole thing, and when you select on the simulation, these options will disappear. Okay, so we don't want to convert that original model. What do you want to do? We want to convert the results, because if you convert these original models, the DC locations will not come there. We want the DC locations, 2 DC locations, we want to add the additional costs, and then we want to do the further analysis. Is it clear? So that's why now what I am doing, I am going to this the result 2, where we have got these 2 distribution centers, and then I am clicking right here, right click, convert to a new scenario. Convert to a new scenario. There was some confusion about the convert and import or export. Suppose I want to export these results into the Excel file, then select export. I don't want to export the file now. What I want to do, I want to convert this GFA greenfield analysis into the simulation scenario. That's why I am selecting the convert. Then it will ask you, do you want to convert into the GFA, NO, network optimization and simulation? I am saying simulation. Convert. As soon as it's done, so you can see this, that results has been converted into the simulation, and you can see 3 files are there. Already 2 files, scenarios are there basically. I am trying to close it. Okay. Done. So what additional cost we want to add here? Tell me. What additional cost we want to add here? Yes, I'm just trying to look at the, yes. So the warehousing cost, operating cost at each DC. Operating cost at each DC is $66 per day. This is the cost we want to add. And outbound processing cost. What is this outbound processing cost, guys? Any idea? From distribution center, you are moving the goods to the customers. So that is the outbound processing cost. Okay. Warehousing cost, managing the inventory within your warehouse. That's your warehousing cost. Outbound cost, it will come when you are moving the goods from outside that distribution center. So outbound processing cost is at 10 USD per meter cubic. Fixed warehousing cost is defined as other warehousing cost, inventory holding cost as a carrying cost. Okay. So those are the things. But before that, I want to show you what is the simulation experiment basically. So here you can see, in simulation, we can analyze the performance of a behavior, performance and behavior of supply chain dynamically over time. So if you want to see dynamically what's happening in the supply chain, your logistics, warehouse, for that purpose, normally we go for the simulations. Okay, if you want to understand any system or any the model, for that purpose we do the simulation. So in our case, we are going to analyze the performance of the supply chain design in GFA, and then we are observing its behavior dynamically. The static view of supply chain is the GFA. GFA we don't do it the dynamically time, but we are converting into the simulation zone. So simulating the effect of 2 new distribution centers. The GFA suggested us 2 new distribution centers, and we are going to see the behavior, the performance of these 2 new distribution centers on the overall supply chain. Then we are evaluating how well these 2 distribution center will help us to achieve our maximum service distance criteria, that is 300 kilometer. So we are going to understand the impact of new facilities on supply chain efficiency, identify potential improvements for cost reduction and service level. So KPIs. Yesterday I have shown you how to add the dashboard, KPIs, key performance indicators, statistics. So here any logistics groups all the KPIs basically into 6 category. KPIs for the distribution centers, KPIs for factories, distribution centers with the storage, then with the staff, customers, suppliers. So based on your interest, suppose if you want to find out the KPIs related to the DC, if that is your interest, then you can say how much inventory is available there, on hand inventory, in processing inventory, because there are various categories of inventories. You can select that one. Suppose you are more interested in the service level, you want to focus on the service level, you want to make sure that you are satisfying the demand on time. So then you go with the operational level performance KPIs for customers. Select those KPIs and then it will give you the results for those the KPIs. Predefined KPIs can help us analyze financial, operational and customer performance. So all these 200 KPIs, they normally grouped into these 6, but in broader way you can see those KPIs in financial, operational or customer performance related. KPIs classification. Finances, suppose if you want to see the profit, revenue, transportation cost, tariffs, inventory cost, anything, then you go with the finance category and then you will find all those the performance KPIs there. Distance, again suppose you are interested into how much distance you are covering to satisfy your customers demand or moving the goods distance. And then products, again how much products customers are ordering, how much products you are delivering. If you are interested into the volume, you can do that, or if you are interested into the orders, you can find out how many orders you have received. Orders is their ratio. So in the ratio, suppose there are a couple of the ratios like expected lead time, service level, and if you want to find out what was the demand we received and how many products we delivered, that will show us some kind of ratios. Time, again lead time is there, processing time you can say, ideal time. Vehicles, again sometimes if your company is retail related, logistics, or if you want to focus on the optimization of the vehicles capacity, because you want to see whether your trucks, vehicles are running empty or whether they are following less than truckload policy or full truckload policy, then you can analyze these vehicles KPIs and then you will find that. Cash to serve, again financial flow. CO2 emission, again very interesting stuff. You can add the CO2 emission generated because of the facility, because of the transportation vehicle, because of the processing. I will show you that as well, how to add the CO2. Other again some other statistics. Custom table, if you want to this is a table created by the user within the AnyLogics environment. If you want to convert it, again this feature is available in the academic version because of the customization table. Preset, it will give you the profit, revenue and cost. Our case study, in our case study we are going to continue the financial performance. Basically transportation cost, we are going to look at the transportation cost, fixed warehousing cost, total cost, profit and revenue. Customer ELT service level. What is ELT? Expected lead time. Okay, so there are basically two service level. I will explain it. ELT service level and normal service level. If you want to find out the delayed orders, you can find out the delayed orders, lead time. AnyLogics uses two types of service levels. First one is the normal service level and second one is the expected service level. So what is the difference between these two service level? So first service level, it measures the probability of all customer orders that received between a specific time, and then it will also focus on whether you can deliver those orders within your time period or not. Within a given time interval will be completely delivered from the stock on hand. So basically, based on the available stock, this service level will try to find out the probability whether you can deliver those orders or not. If there is no stock available, it will, what will do? It will simply, if stock is not available, what will happen? Tell me, suppose you receive the order and you don't have sufficient stock, what would you do? Back order is the one option. What other options? What is it? Ask the supplier to deliver. You are the distributor, you receive the orders from the retailer. Okay, you don't have sufficient stock. You are saying one option is backlog. What is the other option? Yeah, another supplier. It means that you are taking the order and you are saying that I will deliver after some time. Am I right? Yes. But what is the easiest option? Reject the order. If you don't have the stock and if it is not allowed to take the back order, the first option is reject the order. Okay. So service level, it follows that approach. Service level, if there is a stock available, then only it will take the order and then deliver it. Okay, so that's your service level. But there is another service level. It is called ELT, expected lead time service level. So it shows it is the ratio of orders delivered within the ELT to total orders. I will show you in the tool. When you define the demand, so it will ask you what is the expected lead time of each customer. Okay, so when that distribution center or when that facility receives the order from the customers, in ELT, in normal service level, if stock is sufficient, then only it will take the order and then it will satisfy. If stock is not there, it will reject. But in ELT service level, it will always take the order and it doesn't consider whether the stock is available or not. Why? Because back ordering is allowed in the ELT service level. The service level does not allow the backlog. If a supply chain can't fulfill the order is simply rejected in the normal service level. But in the ELT service level, it includes the order backlog and transportation time to the customer. So that's the difference between your service level and ELT service. So for both distribution centers, our fixed operating cost is 66 USD, and then the outbound processing cost is 10 USD per meter cubic. Okay. So now run that model, add those costs and run the model. And tell me the profit. Have you converted the results? Add what you want to do? You want to add these two costs. Sorry. 66 USD warehousing cost and then 10 USD the outbound processing cost. You can first, to locate the first cost, you will find one table there, facility expenses. In the facility expenses, add 66 USD. Do you need to define anything else, guys? Once you define these two parameters, do you get any error? Don't import the Excel file that I have given to you. Otherwise you won't understand. Just add these two costs into the just converted simulation scenario and tell me what is happening. Look at here, I'm showing you. So this is my converted scenario. Okay, so I'm checking look at here, I'm checking the simulation. Yes. Okay, so in use, customers, do you need to change anything in the customers? No. DCs and factories, GFA DC1, GFA DC2. These are the two DC located, DC1, DC1. Okay, and initially open. What happens if you turn off this? So it will consider as a potential location. Inclusion time consider. Why capacity is 0? Why capacity is 0? Any guess? Yeah, go on. Why capacity is 0? Here, capacity is not the input parameter. We are not restricting anything. We are not restricting the capacity of DC. We are trying to find out the capacity of DC. Okay? So whatever the demand is there, on the basis of that demand, distribution center will find out the capacity automatically. But in some cases, suppose you have got the input data and the capacity is restricted 4,000 meter cubic, 3,000 meter cubic, or you can keep only 3,000 products. You can add that here, and then whatever the demand is coming, whatever the supply is coming, your capacity will not go beyond that. Okay, so here 0 means we are allowing the tool to find out the capacity based on the customer's demand. Capacity unit, aggregate orders, all those things. Demand, 10 products, 10 customers, 10 demand. We don't need to change anything. Revenue, do we need to add the revenue here? Do you need to add the revenue here? Currency USD. What is this ELT? What is expected lead time? Tell me. What is the expected lead time? 30 days. What does it mean? What is lead time? Yeah, the ordering point when you order it and when you received it. 30 days means whenever that customer is placing the order, after 30 they are expecting the order to be received in next 30 days. So time unit is day. Suppose if you want to convert that day to hours or something else, you can do that one. Minimum split ratio. So this is the basically suppose if you want to distribute the demand, you want to split the demand, you can do this, but currently we are not doing it. Back order policy is allowed. Back order policy is allowed. It means suppose customers have placed the order and the DC does not have the stock, it will still take the order and then it will send the order whenever they have the sufficient stock. Okay. Suppose if you don't want to add allow this, you can stop it, not allowed. So this is allowed back order policy. Then groups. What is the purpose of groups? Yesterday I told you. What is the purpose of groups? Facilities together, and we can save some computational time, complexity. Suppose here, now let me see the connection. So from here, how many customers DC1, how many customers it is serving? 3 and 3, 6 total. We have got 10 customers. Why can't I see the next customer? Where is the another customer? Yeah. So behind this GFE DC, if you stop this DC, you can see. This is the 10 number customer. Okay. So what is the purpose of this grouping? I can tell you. So from this DC1, it is serving the 6 customers. Now what you can do, in the normal situation, you need to connect when you decide the path from that DC number 1 to all these 6 customers. In the normal case, you need to individually connect. So you need to create the 6 rows. 6 rows. DC1, customer 1. DC1, customer 2, 3, 4, 5, 6. So that's the way normally we do. But when you group those 6 customers in one group, then you need to create only one row. So from that one DC, you can directly connect to those 6, that new group, and that's here we have done it. So here, GFA DC1, you can see, we have grouped the 6 customers. Can you see? So in the path and other tables, we don't need to select the individual customer. You can just select this group name, GFA DC group, and that's it. Then you don't need to do anything. Customers again, and DC, we have grouped the DC as well. Okay. Inventory. Where do you keep the inventory? GFA DC, no replacement. Just again for the simplicity purpose, I will tell you all the policy types. This is a no replenishment. Okay, and policy parameters, we don't need any policy parameter for no replacement because we are just running the model considering some initial stock. So this is the initial stock available, 3,996 at GFA DC1 and 3,108 at GFA DC2. Okay. So now we'll talk about little bit about the policies. Let me see. Okay, policies. Okay. So what is cross-dock policy, guys? Have you heard this term cross-dock? Have you heard the cross-dock? What is it? What is the difference between cross-dock and warehouse? You might have seen Walmart's, all those big players, Amazon, they use the cross-dock. Satellite vehicles. Okay, for what purpose they were using the cross-dock? Okay. Okay. Anyone else?
Coming to delivery, like the delivery boys are taking the parcels. Whenever they are bringing, they are are not bringing the parcels to that particular customer. They
Hmm.
will reserve the parcels.
Mhm.
They will deliver.
Okay. Anyone else? This is very famous term, guys. If you are studying the industrial engineering, supply chain and logistics, and if you don't know the cross dock, transferring the item without storing. From where? Yeah, yeah, that's correct. So cross docking basically, it is a similar kind of warehouse, but in warehouse we keep the inventory for more than like 1 week, 2 weeks, for months, longer time. But in cross dock we don't keep the inventory for more than 24 hours. We don't keep the inventory for more than 24 hours to save the inventory cost. So basically what happens, suppose there are 3 suppliers are there. Suppose I am a customer, I want suppose 3 kinds of product A, product B, product C, but I want the 50-50 quantity each. Okay, and I place the order to the 3 different suppliers. Okay, so 3 different suppliers are there. Then what those 3 different suppliers will do, supplier A will bring the A products, supplier B will bring the B products, and supplier C will bring the C kind of products. So they don't, if they want to deliver me directly, my quantity is only 50 products. So they will run the empty containers, less than truckload containers to transfer my demand. Okay, sometimes they can do the milk runs as well, but if they want to individually deliver me the orders, my order is only 50 products, so they cannot satisfy the full truckload capacity. So what they will do, they will run the full truck capacity until that cross dock. Once they get those cross dock, what they do, they unload all those 3 vehicles, and then they have got the small delivery vans just standard there at the other end of the cross dock, and they will take the goods from these big trucks, and they will load the small vans according to my demand. So my demand is I want 3 kinds of product A, B, C, 50-50 products, and then they will deliver those products to me. So that, and again within 24 hours they will deliver the products. They don't keep it for maximum time. Okay, so that's why this is a cross dock policy. So when you select the cross dock policy, so it doesn't ask you to select any policy parameters. Why? Because we are not keeping any inventory there. Within 24 hours we are delivering it. So cross dock. And what is this initial stock? What is this initial stock? Initial stock means we are running the model for 1 year. So at the start of, when you start the simulation, when you start the model, you need some stock to deliver the orders, because we are saying that the order will receive on the first day when you start the model. So when you receive the order, you need to satisfy it. So initial stock is that stock initial to run the model, and once you run the model, then according to the inventory policy, it will get replenished from the supplier. So that's your cross dock policy. What is the minimax policy? Again, very important. If you are studying the supply chain logistics, all these inventory policies are important. What is minimax policy? When stock reaches to minimum level, you order. How much you order? To the full capacity of the inventory. Let's see, I selected the minimax policy, and what is it asking me? I selected the minimax policy. What is it asking me? Minimum, maximum. You keep it here. Minimum. Suppose I say minimum is 100 and my maximum is 500. Tell me, how does this policy work?
When it is the stock reaches to the 100, the academy is after the 500 units of product.
500 units of?
400 units of.
Suppose my minimum level is 100, but suddenly I received the demand and my minimum level dropped to 50. So my minimum level is 100, but my current stock is 50. My current stock is 50. How much do I order?
500. Because the practice from the current year. So because in the lead time, demand may come and it may become more. So
Yeah, go on. Yeah, lead time is important. Yeah, because when you define that safety stock, you need to consider your inventory level. So minimax policy, you have given almost right answer. So basically, how does this policy work? As you said, minimum level stock at your warehouse is 100. Okay, when your current stock, this is your minimum level, and I am talking about the current stock. Your current stock reaches to this minimum level 100, or when it goes below that, so you place as an order of how much, whatever your current level and whatever the maximum level. So you can subtract that and you can order whatever you want to order. That's the, suppose your maximum is 500, your current level is 50, so you can order 450 to reach that maximum. Or suppose if you want to order 300, you can do that. It's up to you how much, what is your current level, but you cannot go beyond that 500. So that's your minimax policy. It is also called small s and capital S policy. Okay, so in industries they use this kind of policy. So please try to understand this inventory policy. So then we have got another policy. It's called minimax policy with what? Minimax policy with safety stock. What is safety stock? So now here if you see policy parameter, minimum max value, here is the safety stock. What is the purpose of safety stock? To avoid the stock outs. Do we use the safety stock in normal times? Do we use the safety stock in normal time? Whenever we receive the unexpected demand and when we struggle to get the products from the suppliers, then only we use for the safety stock. Okay, so that's the second policy. Third policy. Then next one is the RQ policy. What is this RQ policy? Anyone has any idea? Now SS is done, minimax is done. Now what is RQ? R and Q. I think other day you were talking about EOQ, am I right? Economic order quantity. R is the reorder point. Okay. What is Q? Quantity. Okay. So my reorder point is, say, 150. What is my quantity? 600. Tell me, interpret this policy. When your stock reaches to 100, how much do I order? Yeah, R is 115, quantity is 600, Q. And my current stock reached to 200. My current stock reached to 100. How much should I order? 600 minus 100. Okay, good one. Anyone else?
600 only, sir.
Why?
Because that is the 150 will place the order.
When you will?
Reach that 150 level,
Hmm?
only will place the order.
Yeah, that's the rule. But what I'm saying, before reaching to the 150, I suddenly receive the demand and my current level is 100. My current level is 100. Yeah, I know that we should place the order when we reach to that reordering point. But because of sudden demand, my stock reduced to the 100. Now what should I do?
When it was around 150, then we must have ordered that it was 600.
Okay. Good analysis, good critical thinking, but the very easy logic behind this one. The difference between minimax policy and RQ policy, in minimax policy, the first minimum level is same. There we call it as minimum or small s. Here we call it as R. Reordering point, they are same. The difference between how much you are ordering. In minimax policy, you find out the difference between your current level and the maximum level, and you order up to that point. Up to that point. Okay? Here, we don't consider that one. Whenever our stock reaches to 150 or below that, we every time order the 600. Fixed quantity. Whatever the stock, whether it is 150, we order the same quantity, 600 every time. That's the difference between your minimax policy and RQ policy. Is it clear? Then regular policy, order on demand. Order on demand, basically whenever you start making the products, you get the products from the supplier. And then we have got the regular policy as well. Suppose if you want to do something regularly, so that's the regular policy. Periodic check, period, and then, but in our case we said no replenishment. Quantity, policy type, stock calculation window. If you want to see the window, how when do you wanna calculate the stock. Split ratio is also there. Suppose if you want to do anything. So inventory is done. Suppose if there is a factory in this case, what do you do? If there is a factory involved, suppose in addition to two DCs, suppose somewhere here factory is involved and that factory is supplying to these two DCs. Do I need to change anything in this table? Suppose factory is there. Do I need to change anything in this table? What happens at factory? Manufacturing. Do we keep the stock at factory? We keep the stock. What happens? When you get the raw material components, we keep in the storage. Okay, storage room. When you make the products, finished products, we keep outside in a store whenever finished products. So basically we keep the stock at factory as well. Okay, so that's the, suppose new, yeah. Inventory, yes. So here again, suppose there is a factory involved, you add that factory, then you select here, you can see all the options, you can select that factory, and then what is the product. But again, finished product, suppose this is your finished product, then you keep the stock of the input material as well, raw material components. Then we need to say that, raw material is there, component is there, that inventory will also there. Inventory is then locations. Okay, so locations, all these 12 locations are there. Paths. Okay. So what is the use of the paths table? What is the use of paths table? Paths, basically you need to define the transportation cost here. Okay. So transportation cost, I am saying GFA group. GFA group means the new groups that we created, where we basically grouped the two DCs. GFA group, all locations we are saying, and look at the transportation cost calculation. This is again very important. Product and distance based. Tell me, how do you calculate the transportation cost? How do you calculate the transportation cost? What does it mean, products and distance based? Based on the distance. Okay. But what does it mean, this product and distance base? So we are considering product and distance. Okay. And then you are saying cost calculation 0.05. What does it mean? How do you interpret this 0.05? Tell me. 0.05 whatever USD per what? Per what? 0.0 per unit. What unit? Product. 0.05 USD per product, per meter cubic. Done? Okay. Is it clear? Is it wrong? It is wrong. Why? We are only considering the product. What about the distance? 0.05 USD per meter cubic per kilometer. Why you are removing the kilometer? If you are only considering the product base, then consider 0.05 USD per meter cubic. But here we are saying 0.05 per meter cubic per distance. And distance, it will automatically calculate that distance. Suppose if you want only the product based, then there is option as well. Product base. You can select product base, and then it will ask you, okay, this is my cost, add cost CO2 and CO2 emission. If you want to add, you can add here. Okay. So what we are doing, product and distance based, and then you are adding that distance based cost. 0.05. How much is what? Yeah, 0.05. And this is the table where you define the CO2. Suppose if you want to define the CO2 emission of the transportation, you can define that CO2 emission here. Okay. So at the moment, I am not defining anything. Currency, USD, distance. Do we need to define the distance here? No, we don't need to. Why? Because it will automatically calculate. We are defining the latitude, longitude, exact locations. So it will automatically, and it knows the speed as well, speed of the vehicle. Transportation time same. But suppose, for example, there is a sea route. Okay, and if it is taking the direct route, but if you know the exact distance, or if you want to mention the time, you can mention the time. Then it will take this time. It will not automatically calculate. It will take the time and distance from this table. Straight. What is this straight? Let's see if we make it. So currently this is the one. Okay, straight. Okay. Let me see first how we define the vehicle. Vehicle type, I am saying truck. Vehicle type, we are saying truck. Capacity 50 meter cubic, and speed is 80 meter cubic. Okay. Someone was asking me, Aman, you were asking me what happens if the demand is speed of the vehicle is different, vary. You can see this option here, and then you give the uniform distribution. It will ask you what is the minimum speed of vehicle, what is the maximum speed of vehicle. Okay. If you don't want to take the average, so I am taking value and I am saying 80. Done. So customers, DC factory is done, demand done, groups done, inventory done, locations done, paths, GFA group, all location, product distance based 0.05. Okay, this is done, distance done. Okay. Yeah.
Sir, if we have such kind of situation in which we have to, like, in the half of the path we are transferring to truck, other half is transferred to rail.
To rail. Yeah, you.
How we can add
Vehicle type, you add the rail here. Okay, add the rail, define the capacity unit, it will automatically take. Whether it is a rail, you can add the aeroplane. It depends on here what you are defining. Okay.
in a particular path, if we have to transfer that load, like if we have to ship something from one container to
Other.
so it will come from the road transport also,
Yeah.
maybe from here also.
Supply. So you are saying supplier to DC, it is road, and from DC to the next entity, it is rail freight or a sea freight. Am I right?
No, it may be from the supplier
Hmm.
to the facility also.
Hmm.
It may be different.
Different. Yeah, one may supply by road and another may supply by the.
No, one may supply two type of transportation,
Hmm.
like may road plus the sea.
Yeah, we can do that. Here, suppose then basically you need to just correct me if I am wrong. So you are saying from A to B you are sending, but you are taking the break in between, and then from that point you are sending with the other mode of transportation.
We have to supply something or like metal from India to like outside. So it may be going from the place to the seaport, and then it will be going from there to America.
Yes. Yeah.
Rail also and the sea also.
Yeah, it will come. So as I said, I have got the example as well, that cell phone company where suppliers are located in China, they use the sea freight, then air freight is there, and the road freight transportation is there. All three kinds of transportations are there. I will show you that example as well. Okay. So vehicle type. So we don't need to define anything here. Just let me remove this one. Paths. So the purpose of this straight path, suppose if you want to see the straight path, you can see. But if you want the exact zigzag, then you turn off this, then you will see the zigzag path. Okay. Periods done. Products. Water, we know. Selling price. What is the selling price, guys? Selling price. Suppose water bottle something like 100 or 200, some water, whatever it may be, and cost is say 50. So then you can see the basically the profit for one product. You can get the 50 rupees. Shipping. So GFA group mean 2 DCs to the what we are doing, all sites. No, we don't want all site, all customers. Look at here. What I am seeing, I am selecting the group, GFA group, where we have the 2 DCs. What I am saying, from those 2 DCs, the product should go to the all customers. I am not assigning that one. It should goes to from this to this DC. So I am saying it should go from. It can go from any DC to any customer. Vehicle type truck, and what is this type? LTL. What is the LTL? Less than truckload. Then you have got the FTL, full truckload. Then FTL with the periodic check. What is this FTL with periodic check? Periodically they do the checkings. FTL. So when you define the FTL, guys, it will ask you minimum load ratio. What is minimum load ratio in FTL? Full truck load, and it is asking you the minimum load ratio and period. What is minimum? We are saying that the vehicle should move with the full truck load capacity, but why is it asking the minimum load? Because sometimes it is difficult to fulfill the whole capacity. So we can say that if your vehicle is 90% full, you can go. So that's the meaning of minimum load. Full truck load, but we are saying that it should not go like 60% or 70% loaded. It can go 70, 80, 90. So you can define that ratio here. So if you say 90, when the load products cargo inside that vehicle, when it reaches to the 90%, that vehicle will move from that point. So that's the meaning of minimum load ratio. And the periodic check means it will do the periodic checking of the orders, and accordingly it will check that minimum load ratio. Priority. What is FIFO? What are the some other options? LIFO means? Any example, real life example of LIFO? LIFO? Which queue? Queue of a petrol pump. How? Last comes, first goes. Piles of plate, yeah, good one. Any other example? Yeah, loaded truck. When you load something, you take anything else. You are missing one important in regular daily life. I don't know whether you have got the lift in your hostel or not. In the lift, last person comes first. Okay, so those are. So it's again how you want to deal with the orders. So first in, first out, and then you have got some other option: big first or ELT. What is ELT? Expected lead time. If you want to focus on the lead time, you can do that one. Or big first. Days of week. Okay, and what is the start time and end time, guys? What is the importance of the start time and end time? Why is it asking in the shipping table?
Because it is the limit only we need to send that product to customer.
No, that's the expected lead time, 30 days. What is the start time and end time?
Starting of the shipping travel.
Okay, starting of the. Suppose I am selecting the day Monday, 12 a.m. to 11:59 p.m. What does it mean? So here what we are saying basically, when they can deliver the order. Okay, so from morning start time 12 a.m. to 11:50. Suppose if you order something, I don't know here, Amazon or all those things, sometimes they deliver 24/7, not 24/7, like during the daytime. So if you want to restrict that daytime, because in logistics sometimes the big trucks, they cannot enter into the main city during the daytime. They have to enter into the night. So sometimes I regularly do the online grocery from Ocado. So what happens? Ocado start time starts at the 6-7 o'clock in the morning, and it ends into the 11 o'clock. So they follow these kind of structures. When do you want to deliver that order? So start time and end time. Sourcing. Okay, so shipping is done. Sourcing. GFA DC Group 1, first DC. So water, first fixed source, because we don't have any suppliers here. We are saying that stock is available there. First fixed source. Look at here, guys. What options you have in the sourcing? What are the sourcing policies? Single sourcing, multiple sourcing. Okay. So here, cheapest dynamic sources. Suppose you have got 5 suppliers. What does this cheapest means? Your focus is on cost. Second one is cheapest fixed source. You are focusing on the cheapest, but every time you are going with the same supplier. Closest lead time, closest fixed source, fastest dynamic sources, fastest fixed source. So currently we are saying first fixed source because we don't have any suppliers here. Basic period, vehicle types already defined. but we haven't defined the facility expenses. So go to the facility expenses, add the table, and then select the GFA group, and then other cost. And what is that cost? 66 USD per day. And then you want to outbound processing cost. Okay, so let me see. Processing cost. Processing cost, add the processing cost. I am saying processing cost at GFA group, water, outbound shipment. What is that processing cost? 10 USD. Okay, do you want to run the model now? Let's see if it is valid. Yeah, valid. Simulation experiment. Experiment start all periods. Random seed, you don't need to define anything. Financial statistic USD, meter cubic, day. Some error is coming. I don't know. Let me see what's happening. Add those two costs and run the model. Have you run it? So it's running now. You can make the simulation faster as well. Can you see this bar? Now this is the simulation time. So we are running for the 1 year. Can you see this is running in the January? So now after that, February will start all those things. Now I want to make it fast. Select this bar. Done. 1 year is done. Then now it stopped working. Just give us some time. Okay. So this is your total cost, revenue, profit, average cost per item. Okay, suppose I want to see the profit and loss. Let me see, profit and loss is there. So this is your profit loss, inbound processing cost, outbound processing cost. What is my profit? 502,611 million. So sorry, 2,611. Have you got this result? You can now import the Excel file and you can check the result. You might get the different result. Why? Because the parameters, the transportation cost I have inputted is different one in the Excel file. Import that Excel file now and run it. This should be the answer. Okay, you should get this answer when you run that imported file, because what parameters I have inserted here, those are different. So other cost is 48,000, outbound processing 70, profit is 447. In my case it was higher little bit. Why? Because the selling price and the cost was different. Are you getting? Which cost? How much profit you are getting? Profit is negative. Who is in loss? He is in loss. Okay. Tell me, who is? What's your profit? Is anybody going in loss? हाँ? हाँ, हो जाएगा ना? हाँ. Guys, take the 5 minutes break. Have the tea and then. This is not the imported file, am I right? Imported file. Okay. What is all that? Not 422. guys, profit is coming negative. Why? Why is it coming negative? Any idea? Because if you look at the product table, selling price is 1 and the cost is 1. There is no profit. That's why, because but if you look at my example, I made the selling price 100 and the cost is 50. That's why my profit is 600,000 completely. So exact data is given in the Excel file that I was given you. You can see the file here and see the data. Many of you got this result. Some of you were getting the profit in negative because of the selling price and cost. Selling price and cost was 1-1. You can check the exact data in the Excel file that I have given. Are you getting this now? What is the profit you are getting? 700 something? 702, 400? Whatever it may be, you are getting the profit in positive. Am I right? If you are getting different profit, it is because of input data. Okay?
Now tell me the lead time. How do you calculate the lead time in the result?
There is an option. There is an option to add the lead time. Okay. Suppose I run this model. Now I want to find out the lead time. Look at here. Go to these pages. I am selecting page. Okay. And then I am adding new chart. I am going here and I am saying I want the time. Time, I am saying lead time. And then I am saying okay. And I am saying I want line chart. Okay. This one. So this will show you your lead time. Okay. So this is the lead time. Okay, let me open the input scenarios. You can see if you observe this one, you can see small products are moving. You can see here. Can you see? Small products are moving from this DC to this customer. So this is the results of the Excel file, exact data. Okay. So you can see profit, total cost, revenue, everything. Now, if you look at the lead time is, how much is it? 0.8 days. 0.8 days. Suppose I want to add any new table. How do I do that? Go to these pages, select new page, go to the add new chart, add statistics. I want time, maximum lead time, production lead time, or say I want the inventory data, products, available inventory in products, or if you want to see vehicles, how many vehicles you shipped. Okay, so vehicles shipped, and then select apply. So in 1 year, both DCs have shipped the 732 vehicles to satisfy that demand. And if you want to convert into the different format, go here, settings, line chart, histogram, bar chart, suppose I am saying a line chart. And I want from each DC now. This is for 2 DC. I want from each DC. So I am selecting object type DC. Okay, DC. Sorry. Let me see if it is come. Shipped vehicles. Okay. So this is from DC. Let me see. You can see from DC 0 439 vehicles and from DC 1 293 vehicles. So you can do this in-depth analysis as well. Suppose if you want to see the how much inventory available at each DC, how much time is taken, all those things you could do here. Okay? So this is the our 2 distribution center analysis. Okay. So now we want to change the location little bit, these locations, because we don't know whether it is a mountain or exact location. So now we want to change it little bit here randomly. Then what I am doing, I am importing that scenario, change the location, and I am importing that one, and I am running it because I know it's fine. And the second option, guys, what is these 2 running options? This first one is if you want to see the visualization here. If you don't want to see the visualization, select the second one. It will run without the simulation, and then it will give you the solution. Okay, so this is my location, because if you look at the location of DC here and in this one, so this is the location original. Now we are changing it little bit, we are moving here, and this is coming here. Okay, and now we are going to see what is the impact on the solution. So now results are here. So what was the profit in initial case? Exact location profit was around 700 something, am I right? Now let's see how much is it coming. Profit is coming 422. It means it reduced. So these two locations are not good, existing locations are good. And here in this table you can see demand received products from the customer 7104 meter cubic. This is the product quantity. And if you want to see how much orders received, 732 orders received, and 730 orders shipped. So you can find out that as well, how much orders you received from the customers, how many orders you delivered on time. Suppose if you want to find out the delayed products, so delayed products, how do I do that? So you can do one thing, you can go here, and if you can select what you demand products order backlog. Order backlog is not there. Why? Because we are not considering that backlog. Fulfillment, demand place. Then if you want to add anything new, what you can do, add statistics. Go to the add statistics, and then orders. You can select here late orders. Can you see fulfillment late orders? You can select that late orders, and you can see if there is any late orders. If there are any late orders, you can see here. So whatever the statistics you want to see, late orders, back orders, or inventory in hand, on and then other things like, let me see, peak capacity, on hand inventory is there, production place, peak capacity, many things are there. So it depends on your problem requirement, what KPIs you want to analyze. So this is the second one, third, and fourth one is the the 1 DC. We initially run the model for 1 DC. So let me run that as well. We don't know whether, because of the addition of these processing cost and the facility cost, whether single DC is good or two DCs are good. So we will run the single DC's model now. Single DC, we have added the processing cost here. You can check here. What is that processing cost? Can you see? Facility expenses, 66 USD we have added. Then we have added the processing cost as well. Processing cost, you can see 10 USD meter cubic, and for all periods. Then, so now let me run it again without the visualization. I am running it. Then profit is 420. Okay, so now let's see the results. These are the three results, basically 3 cases. So first one is the DC, 2 locations, two distribution center, profit, revenue. In all 3 cases, revenue is same. Why revenue is same? Demand is same, is revenue is same. What has changed in the second case? Your profit went down, 422. Demand remained same. Why profit went down? Why? What is the difference between first and second? Why it changed? Because of location. Because here we consider the exact location. Here we slightly changed the location, and because of that you can see it affected the transportation cost. Originally it was 135,000. It went to the 160, and that's why total cost increased to 279,000. What about the lead time? It was initially 0.8 days. Now 0.95. Again, why it changed? Because of the location. Then similarly, single DC. Single DC is other cost. Other cost decreased here, 24,000. Why? Distribution center processing cost. Because in first twos we have 2 DCs. Here we have only 1 DC. That's why processing cost reduced by 50%. Outbound processing cost is same. Outbound processing cost is same for all three cases. Why? What is it related to? Processing cost. For all three cases it is same. Why is it? Is there any problem in the results? Processing cost, how much orders you are delivering. So in all case demand is same. We are delivering the same amount of orders. That's why processing cost is same. Okay. Then profit, you can see it reduced here. Revenue same. Total cost increased here. Lead time again increased. Service level, this is without the back order 100% because it doesn't allow any back order. Customer delay orders, have you delayed anything? No, zero. Then customer in time orders. In all three cases, we managed to satisfy the orders on time. Why was it? What is the reason behind that? Have you noticed anything in that table? Expected lead time table. What was the expected lead time? 30 days. This is a good amount of time because we are moving from one location to very nearby location. We are not moving other country or other continents. Okay. Then customer items arrived, customer orders arrived, backlog orders, item shipped, order shipped. So this kind of analysis, KPIs analysis you can do, and then you can do the make the recommendations whether you want to go with the single DC, double DC, or 2 DC. So now, what is the analysis? It previous table shows the one distribution center has lowered the distribution center cost, related cost, but transportation cost significantly increased as that's why total cost went up. In this example, we can see the effects of consolidation and centralization. So what do you think? Is centralization good or decentralization? What is centralization and decentralization? One centralization means one DC. Decentralization means we have got 2 DC. What do you think? Centralization is good or decentralization is good? For long term decentralization good. Depending on the product. Yeah, yeah, that's the correct. We cannot say for long term or short term. It depends on many factors. You need to consider the cost. What is your focus, responsiveness, all those things. So here you can see that responsiveness, the trade-off between the responsiveness and the facility cost and efficiency. So on x-axis we have response time. So if you want more responsiveness, what do you need? Multiple facilities. So you can see the more response time, it will come here. You need more facilities. More facilities means more cost. Then what about the number of facilities and inventory cost? When number of facility increases, your inventory cost will also go up. Then transportation cost versus number of facilities. Number of facility increases, transportation cost. Why? Because you need to travel the lower distances. And this is your total response time versus total logistics cost and the number of facilities. Very interesting book. I don't know whether have you read it or not. Sunil Chopra's book, Supply Chain and Logistics. So comparison of efficient and responsive supply chain. What is the goal of primary efficient supply chain? Focus on the lowest cost. Supply demand at lowest cost. Responsiveness, you want to move the good fast, quickly. Product design strategy, maximum performance at minimum cost. Here, create modularity. Pricing strategy, low margins. Efficient supply chain means, you try to get the lower margin there because price is a prime customer driver. Here, responsiveness, higher margins. When you order something from Amazon, what does it mean? If you want 1 day delivery, do you care about the cost? No. If you want 1 day delivery, you go with your Prime account, you pay additional charge. So that's where higher margins get to the companies. Manufacturing strategy, lower cost through high utilization because their focus is on the cost in efficient supply chain. So they use some advanced technologies. Here, responsive means maintain capacity flexibility to buffer against demand and supply. Inventory strategy, again efficient, minimum inventory they need to keep. Here, maintain the buffer one. Lead time, reduce but not at the expense of cost. Here, reduce aggressively, responsiveness. Okay, sometimes they move the goods with the aeroplane, air freight as well. Why? Because of the responsiveness. Supply strategy selected based on cost and quality. Here, speed, flexibility, reliability. So that is the difference between efficient and responsiveness. So again, it depends on the product, the company, what is your customer base. So many factors are there, and on that basis then you select whether you want to go with the efficient one or the responsiveness. So this is very interesting example, guys. I don't know you have heard or not. So KFC's UK logistic disaster. So in UK, in the 2018, what happened? KFC had around 1,000 outlets in the UK, and in February month of 2018, 900 outlets out of 1,000 outlets were closed because of the chicken shortages. And what was the problem behind that shortages? These kinds of apologies notice were there in front of those outlets. We have brought a new delivery partner on board, but they have had couple of teething problems. So what happened basically? The KFC, they changed their delivery partners. They changed their delivery partners from Bidway Logistics to the DHL. You can see here, KFC switched the logistics provider from Bidway to DHL in 2018, and DHL and QASL failed to deliver chicken on time because of 3 reasons. What was those 3 reasons? First one is the poor supply chain planning. Okay, DHL was a major player in the third-party logistics provider, but they did not have any experience of managing the perishable nature of products. They had a pure supply chain planning and single warehouse strategy. So if you look at the Bidwest Logistics network, they had 6 distribution centers located in the UK to supply the 1,000 outlets in the UK. If you compare the DHL had only 1 distribution center located to supply those 1,000 outlets. And that's why this single warehouse strategy didn't work there properly, and they experienced the shortages. KFC 900 outlets were closed, IT and routing failures leading to empty trucks. And then how did they resolve this? So basically impact, financial loss, millions of pounds lost per day, customer backlash, social media outrage, all those things. KFC's famous apology came into the newspaper, and some franchises owners threatened to legalize the actions against the KFC. So how KFC fixed this issue now? So they brought back the Bidwest Logistics, partly because they thought that it is not a good idea to go with the one single supplier, DHL. So they partly brought back the Bidwest Logistics, improved the logistic tracking and supplier coordination. They went with the IoT devices to track the vehicles' locations, diversifies the logistics providers to avoid the sole dependency, and better contingency planning for future risks. Backup plan: if you are one of the suppliers or delivery partners failed to deliver the products, they started the contingency planning. Some of the key lessons learned: cost cutting should not compromise supply chain reliability. They wanted to reduce the cost, that's why they went to the DHL, but it significantly affected their supply chain. Single source logistics strategy is risky. Okay, it depends again on the type of products and the nature. You cannot say that centralization is always good or decentralization is always good. You need to see what kind of product is there, whether it is a perishable or not. For perishable, you need to move those goods very fast. You cannot wait for 4 or 5 days to move those goods. Backup suppliers and contingency planning. Technology and logistics should be well tested before implementation, and crisis communication matters. Centralization, decentralization, couple of comparison. Warehousing cost is lower in centralization. Why? Compared to the decentralization? Yes, that's why. Inventory holding cost lower in centralization, decentralization higher. Transportation cost centralization higher because you have got only one warehouse and multiple outlets. Delivery speed, centralization always slow. Here faster, flexibility low, higher. Demand responsiveness, risk diversification, centralization lower, decentralization higher. Why is it higher? Because you have got multiple DCs. You may face problem for one DC, but not all the DCs. And that's why during COVID-19, everybody was talking about this risk diversification, having multiple suppliers, local suppliers, global suppliers. So how do you select the strategy? Centralization. It lowers the cost, efficiency and control, suitable for businesses with a predictable demand and longer lead time. If your demand is predictable, deterministic, and there is no problem with the lead time, like in our case, 30 days. It's good time, good amount of time. You can move the products from one point to another point. But decentralization, when you need the faster service, responsiveness, flexibility, for example, the e-commerce, retail and perishables, you should go with the decentralization approach. Any doubts? Summary, greenfield analysis helped us to determine the optimal facility locations, input data to conduct a greenfield analysis experiment. So we already talked about this one, the locations table, customers, products, demand. Okay, and what kind of algorithms does it use? Greenfield analysis, K-means algorithm, this Aikin and Babu algorithm, and then estimation of transportation cost. For greenfield analysis, it focuses on the transportation cost basically. Greenfield analysis doesn't count roads, cities or means of transportation, so it may suggest placing distribution center in surprising locations such as top of mountain or in the middle of the sea. So that's why you need to run the GFA with your roads experiment. Okay. So the last part is done. So I have got couple of slides here related to the optimization and simulation. So tell me some of these recent events. Look at these pictures. When did you see these kind of pictures? How are they related? Which recent events? COVID-19? Yes, because of panic buying and then lockdown and border closures. What about this one? Suez Canal. When your evergreen ship stuck into this Suez Canal. So this is the shortest route between your Asia to the Europe. If you close this route, you need to go to this Cape of Good Hope. Okay. So you can see how many ships were waited when this evergreen ship stuck there. Okay. Why I am showing these examples? Supply chain optimization and simulation. Because if this kind of unexpected event occurs, then you need to find out the alternative route considering the whatever the resources you have. Okay. Another example is this one. When Queen Elizabeth II died, so there was a huge queue to pay the last respect to her. So the queue length was around 10 kilometers or something. People waited there for more than 48 hours to pay the respects. So tell me, what do you think about to manage this kind of queues? What is the basically requirements, or what planning do we need to do to manage this kind of events? So or another example. What is this? Mahakumbh. What is our role in this kind of incidents? What, as a supply chain and logistics experts, what could you do? Crowd management. What else? Crowd management, logistics management, traffic management, then risk analysis. If suppose in Mahakumbh stampede has happened, okay, so when this kind of unexpected event happens, you need to find out the alternatives, how to find out the shortest route from that whatever the the point where these things happen, how you can avoid the social losses, lives, how you can properly manage the things. So there are so many applications of this artificial intelligence to manage this kind of. So in that Queen Elizabeth's that incident, so they had taken the help of the the queuing analysis, basically the supply chain experts, to manage that 10-kilometer queue, because you need to have the toilets, waters, all those facility readily available. Okay, otherwise people will struggle. So similarly in this Mahakumbh, disaster plannings, all those things, there are many applications of this supply chain and logistics to to manage these kind of events. So what is optimization then? Trade-off between what? Trade-off between cost and profit. Anything else? Yeah, easy way of. Suppose if you want to go from Varanasi to Delhi and you have got only 1,000 rupees, what would you do? You have got the 1,000 rupees criteria, you have got the 2 luggages, and you have got the time constraint as well, 10 hours only. What do you do? Take lift. I don't know the train ticket as well. Train ticket is one option. Okay. Premium Tatkal. Okay. These are the options. So basically, you consider your resources, constraints, what are my restrictions, constraints, and you try to what? You try to find out the best solution. You cannot go with the flight with your 1,000 rupees. Am I right? Okay. You cannot hire the car as well. Then whatever the resources available, constraints, you need to see those constraints, and then you need to try to achieve your objective, whatever goal. Okay. So basically, do less work for more gain. Then making the best or effective use of situation or resources. So in that case, what are the resources available to you? Money, financial constraint. You have the luggage. Then you have the time constraint. Okay. And what is your goal? To reach to Delhi. Whatever the time is there, 10 hours. So that is your basically optimization. So look at the constraints and then try to optimize or try to find out the good solution, best solution for your problem. So in mathematics or computer science field, if you look at the optimization, it is a problem of finding the best solution from all feasible solution. Okay. So now I want to ask one thing. You all come from the decision sciences background. What is feasible solution? All the constraints. Okay, good. Well done. So all the feasible solutions. So basically you try to find out the optimum solution from all feasible solutions. If your solution is not feasible, then do you consider as a optimal solution? No. Because first you need to see whether your solution is satisfying all criteria, all constraints or not. If you are violating any constraints, then this is a non-feasible solution. Okay, so linear programming is a central topic in optimization. So again, optimization, selecting the best solution from set out feasible solution. You could do the minimization or maximization of profit, maximization of what? Service level. What else? Maximization of, sorry? Profit, yeah, service level. What could you maximize? Maximization of benefits, some jobs, minimization. What about minimization? Minimization of cost, minimization of time, minimization of distance, minimization of CO2 emission, minimization of any risks, minimization of dangers, whatever it may be. What are the key components of optimization? Objective function that need to be optimized, cost, profit, efficiency, constraints, limitation or restrictions. Constraints could be inequalities or equalities. Then system model, mathematical representation. What is the purpose of optimization? Find the efficient, cost-effective, profitable solution. And it is ensure the solution adhere to the constraints. Improve the decision making and resource allocation. Examples: minimizing cost while meeting demand, supply chain optimization. Manufacturing, maximizing production efficiency with resource limits. Resource limits means how many man, machines, labor available at your factory. Finance, maximizing portfolio returns under risk constraints. I don't know whether you do any share market or not, but when you do the your portfolio, you see your rate of returns, what is the risk, and you try to optimize your rate of return. So LP, again, this is a field of operation research and management science discipline. So why is it so famous, LP, linear programming? Because it's because of the applicability. It is a powerful tool for many real world applications. Many real world applications in healthcare, aerospace, any sectors. If you select, you can find the applications of linear programming to to address the complex problems. Then solvability as well, theoretical and practically efficient techniques are available to solve this kind of problem. Basic components, decision variables. What is the decision variable in LP? What is decision variable? What is the difference between a decision variable and parameters? Okay, and what is LP? Decision variables? There is something or no. So parameters means input data. We know the values of those parameters like cost, distance, we know that. Decision variables means we want to find out the values of those decision variables. Okay, suppose if you want to move the goods from one location to another location, you know the distance, you know the cost, you don't know how much you want to move. So that's the decision variable. Objective function, again minimization, maximization, constraints you can see. And this is one example of maximization of your profit subject to these constraints. Examples, again you could see, you have got the suppliers, you have got the distribution centers, and in the second case you can see the factory, depot and the warehouse. Multi-criteria decision making. Any idea? Have you heard this term? What are the categories of multi-criteria decision making? Don't tell me the exact methods. Never. I am asking you the classification of multi-criteria decision making. I know AHP, TOPSIS, yes. Do you know under which category they come? We have got two categories of multi-criteria decision making. One is the MODM, another one is the MADM. What is MODM? Multi-objective decision making. Multi-objective problems. Have you seen the multi-objective problems? Multi-objective optimization. When you have more than one or two objectives. First objective is maximization of profit. Second is minimization of time emission. So that is your multi-objective optimization. What is MADM? Look at the naming. Attribute. Attribute means the quality features. So basically, MODM, it is suitable for the evaluation of continuous alternatives for which we predefine constraints in mathematical programming. So MODM means mathematical programming and we generate the solution there. We don't know the exact solutions there. It provides many alternatives after solving that model. The alternatives are not explicitly known. In case of this MADM, here we don't define or we don't generate any solution. We know the criteria, we know the alternative, we use the method in expert's opinion and we select the best alternative among the given alternatives. So that's the only job we do in the MADM. So examples are AHP, TOPSIS, Vicar, DMetal and so on. So in MODM, we have got the goal to generate the solution, but in MADM, we want to select the best alternative among the available alternatives. So objectives are the reflection of the desire of decision makers like cost, time, attributes, characteristics, qualities, performance parameters. So if you want to select, if you want to buy a new car, new phone, you go with the MADM. Suppose if you want to optimize the cost, time, you go with the MODM. This is an example again, MODM, mathematical programming, MADM, you have the criteria, you have the alternative, you use the MCDM method. What is the input for MCDM method? MADM attribute. How do you get the data? Through surveys, through experts. We develop the pair-wise comparison matrix and we send them to the experts. So this is an example again. You can see three objectives and then constraints and MADM. This is our four criteria and three suppliers. What is Pareto optimal solution? Any idea? Finding the trade-off between two objectives. Okay, have you heard the conflicting objectives term? Conflicting objectives, because when you say the multi-objective optimization, it means the objectives sometimes they come into the conflicting nature. What do you mean by conflicting? When you try to optimize one, other gets deteriorated. That's your conflicting nature of objective. Any example from real life? Time and money. Okay. Transportation, yes. Amazon Prime, yeah. If you want to order a one-day delivery, you need to pay the additional money. Yeah, that's correct. So this is one example. Suppose if you want to go from Varanasi to Delhi or somewhere else, okay. So the ticket type, 5 ticket types are there. Travel time in hours and the ticket price. So ticket A has a travel time of 10 hours and then price is 1700 pounds. What about B? Travel time reduced to 9 from 10 to 9. Ticket price 2000. So do you think that B is better than A? Yes, it is better than A. Our objectives are two. Ticket time and ticket price. So do you think that B is better than A? B is better than A, but in which case? Only one. Travel time. Not in case of ticket price. Look at the C now. Travel time reduced to 8. Ticket price 1800. So do you think that C is better than B? For both the objectives, it is better than the B. So do you think that C is a non-dominated solution? Yes. C is a non-dominated solution. Why? Because it is dominating B in both cases for both objectives. So here on x-axis we have got travel time, on y-axis we have got the ticket price, and then you can see the line that is called Pareto line, and on that line you have got these solutions. Okay. So in multi-objective optimization, you try to find out the solution which are closer to that your Pareto line. So here, if you try to minimize the travel time, ticket price goes up, and if you try to minimize this one, your travel time increases. So that's called conflicting nature of objectives. So that's why when you solve the multi-objective optimization, do you get the optimal solution? Do you get the optimal solution similar to what in our single objective? No. When you solve the single objective optimization, you get one optimal solution. But here, do you get the optimal solution that one? No. Then how do the companies select the solution? Ticket. Yeah, so they can as per their the requirement. Suppose if they are more interested in the ticket price, they will give the weightage. 50%, 60%, whatever weightage they can give. Otherwise, if they want to treat both objectives equally, you can provide these kind of solutions, and then they will select the one compromise solution which is good for both objectives. A purpose of optimization, as we discussed, enhances the decision making by minimizing cost, improving efficiency. Why needed? So basically sometimes simulation alone doesn't optimize it, so it needs to evaluate the scenarios. That's why optimization is needed. Common optimization technique, any idea? Mathematical programming, linear, integer, mixed integer, meta heuristics, genetic algorithm, PSO, tab search, gradient based used for stochastic optimization, just short case. Okay. So there is a one company and that company makes two kinds of shirts, regular fit and deluxe fit. The contribution coming from each regular fit is 5 pound and from deluxe fit it is 8 pound. This is a profit. To make the two shirts, each shirt requires 600 meter square of cotton is available. Machinists are to cut and stitch the shirt. 20 machinists are employed. So they work 8 hours per day. So what is the total time available? What is the total time available? 2 machinists, 8 hours. 8 into, so total giving 160 hours of labor in total. Regular shirt requires 5 square meters and takes 1 hour to make. Each deluxe fit shirt requires 6 square meters and takes 2 hours to make. The company wants to maximize the profit, and how do they maximize it? Can you formulate this problem? Tell me the objective function. Hmm? 5x1 plus 8x2, that's the objective function. What is the first constraint? Cotton constraint. 5x1 plus 6x2 less than or greater than equal to less than equal to 600. What about the labor constraint? Less than equal to? Okay, good. I can now trust you that you are industrial engineering or supply chain and logistics expert. Okay. So decision variables: x1 number of regular feet, y number of deluxe feet shirt produced per day. Objective function maximizing profit, 5x plus 8y. Then constraints: cotton constraint, 5x plus 6y less than 600. Labor 1 hour and 2 hour, x plus 2y less than equal to 160. Non-negative constraint. What does it show? Non-negativity constraint? Greater than or equal to 0. So this is your model. Okay. How do you solve this model? What are the options available? Graphical method. How do you use the graphical method? By find out the coordinates. So if you Plot the first line. Can you tell me the coordinates? 5x plus 6y less than equal to 600. Okay. What about second line? Good. Okay. Good one. So these are the your coordinates. Am I right? Okay. So blue line shows the your cotton constraint. Green line shows the your labor constraints, and where they are intersecting at this 60 50 point. Do you know how to find the points here? So which is the feasible region here? Shaded region. Why shaded only? Why not above that? Constraints are less than. If constraints are greater than, then they will go above the lines. Okay, good one. So then you find the feasible region 0, 0. Then see the objective function 0, 120, 0, 600, 0, 80, 640, 650 means 700. So the solution is x equal to 60 and y equal to 50. Another example, a retail company sources products from 3 suppliers and distributes them through the 2 distribution center and 4 customer locations. And it includes transportation costs, storage cost and delivery cost. Okay. So now they want to optimize the quantities. So this is their network. Okay. Supplier, 3 supplier, 2 distribution center and 4 customers. Okay. Sorry. Yeah, 2 distribution center and 4 customers. Okay. Tell me, how do I formulate the model here? Suppose I want to make the mathematical formulation. How do you make it? So what would be the objective function? My transportation cost is there, storage cost. Transportation cost from supplier to DC, DC to customer, and storage cost of DC. Tell me the objective function. 2 objective. Why 2? What? Yeah, decision variables are 2, but he is saying 2 objectives. But we are saying total cost. Total cost includes your transportation cost plus your storage cost. Okay. So tell me the objective function. Any idea? Transportation cost. Okay, so these are our decision variable. Quantity transported from supplier to DC. Second one is from DC to customer and the inventory available. Okay, this is the transportation cost. Cost from supplier to DC, DC to customer, and then holding cost. Okay, this is my objective function. Is it correct? Is it correct? Check it again. Is anything missing here? What is the difference between this objective and our first objective? Just short example, 5x plus 8y. What is the difference? Yeah, inventory holding cost, but I am asking general questions. What is the major difference here in this and that 5x plus 8y? Okay, that's fine. But again, I am saying that I don't want those details. I want the general difference between this equation and the previous equation. Double summation. Why we have added the summation here? Yeah, that's the one. Because if you see the simple example, that 5x plus 8y. Suppose I want to add the time period here. What can I do? What change do you make here? Suppose time period is there. Currently, we haven't considered the time period. If I want to add the time period in this equation, objective function, one more summation will come. So you need to, so basically when you read any article or anything, this is the way to look at the model. So you should know why the 2 submissions are there. So 2 submissions, it suggests that submission of all suppliers. How many suppliers we have? 3. So when we optimize the whole network. We don't optimize one supplier, one DC and one. We optimize the whole network. So submission of all suppliers means submission of all 3 suppliers, then submission of all DC, and this is a cost, and then the quantity, decision variable. Yeah, go on. So again, yeah, time periods you need to decide whether you are considering continuous time or discrete time. But I am just saying that the time when you add it, so it will become the dynamic nature of the problem, and then that another summation will come there. Okay. And then second one is that another transportation cost and inventory. Inventory again, because when you consider the inventory balance, what is coming, what is going, and what is available. So that's the your inventory. Supply constraint. What is first constraint? Can you explain me? Supply constraint. What does it show?
The total number of supply should be less than a particular capacity.
What is summation of D and X of D less than equal to S? S, capital S and S is the supply of each supplier. What is the meaning of this term? Why it is not this summation side? Why is it coming to the right hand side? What is the
All the suppliers.
yeah, so basically supplier capacity, we are trying to make sure that suppliers should not exceed their capacity. So whatever the products suppliers are sending to the DC, it should not go beyond their capacity. So summation of all D, again we are not considering single DC. We are saying that each supplier, whatever they are supplying to the all DCs, it should not go beyond their capacity. That's your supply capacity. What is this demand capacity? We are saying whatever we are sending from one DC to all customers, it can go beyond their demand, so maximum. Then this is the inventory. What is whatever coming from the suppliers plus inventory available, it should be equal to the outbound flow. And these are your non-negativity constraints. So what is simulation then? This is optimization. Simulation, system representation of reality. So system means it has got two inputs, controllable inputs and probabilistic inputs. Okay, so controllable means we know their values, probabilistic means we don't know their values. We test the proposed changes, identify potential changes, develop major KPIs, examples, assembly production lines, configuring new production cell lines, supply chains. And some of the benefits like observation of time, you can do dynamic interactions in simulation. It allows uncertainty in modeling, help to find unexpected phenomena, means you can predict the delays, what if scenarios. Don't get exact answers here in the simulation, we don't get the optimal solution. Okay, we get the approximate solutions because we vary and some input parameters are random. Okay, random outcome from stochastic simulation and sometimes difficult to interpret results. So models, it models real world supply chain processes, types of simulation models. What are the types of? Yesterday you told me somebody. Static versus dynamic, time dependent versus non-dependent. Then what next? Deterministic versus stochastics. Stochastics means some parameters are not known. Discrete and continuous, how the parameters are changing at a given time or continuously. So benefits, it reduces the risk, improves the forecasting because we predict the unexpected events, optimize the operations. So tools used for supply chain simulation. Spreadsheet, you can do the simulation in Monte Carlo kind of simulation in Excel. Software packages, Arena, MATLAB, Simulation 8, any logistics. Programming languages you could do in Python, C++ or some other languages. Use cases you could use in the inventory management for balancing stock levels, route planning and warehouse operations, production planning. Some of the leading simulation models, first one is the Monte Carlo. Any idea? How does it work? What do you need for Monte Carlo simulation? Sorry, what? Static, yeah, static is there. But what do you need? We need the input and output of your systems, whatever the historical data. Basically, how does it work? It considers the probability distribution and random numbers. And on that basis, it provides some information about the unexpected events that may occur in the future and that will affect your profit, supply chain and all those things. Empirical data needed, input and output, and then identifies the uncertainties. You can implement Monte Carlo simulation for any industry, given that you have the sufficient historical data available. News vendor inventory problem. Suppose that a demand for Valentine's Day card is governed by the following discrete random variables. So this is the demand and this is the probability. And you want the greeting card sales at 4 pounds, variable cost is this one, and the leftover card must be disposed at 20 pence per card. How much should we produce? Any idea? How much should we produce? First is the demand, okay, probability. Then you need to find out the cumulative probability, okay. Then we develop the random number and then we see where that random number lies. Okay, and then you do the calculation. So how does that calculation? So you can see the example of 5 trial here. Okay, random number we generated, and we are assuming the production level is 20,000. Okay, we can do multiple runs, 20,000, 30,000. So 20,000 random number is 13. Okay, 0.13. So you go here and you see where it comes. Sorry. So the random number 0.13, it comes into your second category. Okay. So you have got demand is 20,000 because of that random number generated, and we are assuming the production level is 20,000. What is revenue? Revenue is calculated minimum of production level into demand. Okay, and then multiplying with the 4. Production cost is fixed, production level 20,000, multiply by 1.5. Disposable cost, whatever the cards are left, you find out and you do the profit. So when you do the calculation, what do you find? 50,000. So means 20,000. In most of the cases you are getting the 50,000 profits. If you make 20,000, if you make 30,000, 40,000, 30,000. So 20,000 is good if you want to do. Okay, you can do this kind of simulation, and you can do this in the Excel as well. Do you know how to generate the random numbers in Excel? Rand function. Just use the rand function, and then it will use the one. Agent based simulation to find out the interactions between the agents. Okay, so here you can use agent based rules to find out the some analysis or insights from the supply chain. This is an example, importer and exporter. You can see here, and then you can do the analysis. Okay, system dynamics. I think somebody was using Stella. Am I right? Stella. So is it that the Stella is system dynamic simulation? This is used for the long term prediction. Okay, so in the long term, suppose if you want to find out the GDP in 10 years or the population growth, you go with the system dynamics, and you can find this feedback loop. Discrete event simulation, normally dynamic behavior of complex systems, how much arrival and flow of entities, we can understand those things like goods, information, people, or in the bank or hospital, how many times or when the customers or the patients arrive, inventory management, route planning, and so on. So this is one example of discrete event simulation. Application, you can see where you can use the simulation techniques. High abstraction level. High abstraction means you don't need lot of details. Population dynamics, like if you want to do the population growth or the GDP growth, you don't need lot of information there. But if you look at the middle side, supply chain, transportation, you need more details there. And here load abstraction means more details, again the automotive, pedestrian movement. And then this is a application of those 4 simulation. Discrete event simulation for middle level like supply chain planning, transportation. Agent based you can use for the high abstraction or middle level. System dynamics, as I said, it should be used for the long term. You cannot use system dynamics for the regular daily operations. Okay, so that's the one. Optimization simulation, again of modeling approach, optimization that computes the decision variables, maximizes, simulation, representation of a system, then you can predict the behavior. Purpose, optimization, identifies the best possible solution by systematically adjusting the system parameters here, helps in understanding the system performance, simulation. Use cases, AI driven decision making, here you can see the what if scenarios. Commercial software packages for simulation, AnyLogic, Arena, so on, you can see, and then techniques and the optimizer. And these are the references. Okay, I hope you had enjoyed it. I know I rushed it a little bit at the last because of the time constraint, but you can get the slides. If you go through the slides, if you have any problem, any doubt, just come back to me. I will discuss. Okay. Sorry, do you want the slides? Saurabh will send you all the slides, recordings, everything. Any doubts? in that model? No? I am here if you want to discuss anything. Done. Yeah.
Sir, at last, all those were the different types of
Simulation.
Sir, can you just add some small examples or little examples which are related to that?
Okay, so do you want to some examples of those
Small, simple examples of all these types of
simulation?
the heavy use.
Simulation. Just let me see. So discrete event simulation basically, as I said, you can do when in warehouse when you receive the goods, how much stock is available and when it is going, like our any logistics that is based on the discrete event simulation. Those kind of models you can solve using the discrete event. System dynamics, as I said, if you want to do the long-term planning, suppose if you want to find out the rate of return or something in 5 years, 10 years time, okay, so that you can do in the system dynamics simulation. Agent based simulation, suppose importer and exporter, suppose there is one example available, let me explain that one. Yeah, so this is an example of your agent based simulation. So this is based on the food grain supply chain. So what is happening here, the importer is from the Middle East and they import the food grain from the exporter, Asian country, India, all those things. Okay, so what is the basically the features of this importer? The importer means the countries, those who import the food grain, so they want to satisfy the local monthly demand, grow locally as well, import from the exporters and find the best set of exporting countries. So these are some of their objectives. Agent. Exporter, what is the goal of exporter? Produce locally its maximum, like we are from India, suppose we are exporting the food grain to the UK, US, all those countries. So our job is to produce locally its maximum capacity with the given capacity, export to importer based on its monthly demand. So they will let us know their monthly demand and on that basis we send those things. So how the basically overall things works here, importers attributes monthly inventory. Importer, they see their monthly inventory demand, how much they have locally grown and monthly imported quantity. Exporter, our capacity, how much demand is coming, production capacity, exportable quantity. So strategy, you can say growth strategy, import, you can understand here. Importer means UK, US, who's which countries they are importing. Importer, what they do, they check the inventory. Okay, they check their inventory stock and there are two options. If inventory is sufficient to satisfy their demand, no decision required. If inventory stock, they detect some shortages, they have three options: grow, import, grow and import. Grow means locally grow, import, or grow or import, and then they satisfy the demand. Okay, so this is the high level illustration of importer's logic. So basically, suppose you are the supplier and I am the manufacturer. So basically, when you give me the quote of whatever the products you can supply me, I will see that catalog, and then based on your estimation quote, I can decide whether I want to go with you or not, or I can negotiate with you. That's called agent based simulation. So if you want to try to find out the relationship between when one entity takes the decision and what is the effect of that decision on the other members, for that purpose we use the agent based. Here when importer places an order, and on that basis then exporter decide whether we have the sufficient quantity or not, whether we need to grow additional food grain. So you can say exporter produce based on our capacity, check importer's decision, importer decision like supplier's decision, and then decide whether you want to grow it or you want to import. So that is a application. You can see refer this paper as well, Namnai. So they explain this agent based simulation there. Then you have got this Monte Carlo. We already discussed that case. News vendor, agent based is done. Then system dynamics, again you can see long term level. You can see the impact, the feedback loops are there, inventory, production. This is used for long-term strategic level view of the overall systems. Here you don't need to define the operational level or medium level, medium-term, the parameters. And discrete event is dynamic behavior, understanding and optimizing the flow. Discrete event means flow. The activities happening at discrete point of times in your supply chain. Because systems here you don't need to define the operational level or medium. The do you know? We don't know when will the supply come to us. So these events happen at discrete point of time. That's why it is called discrete event system, and continuously changing time. That's the another reason.